Hi everybody and welcome back to a new video. In this video I am going to be looking at how to write Python scripts inside a QGIS environment. Now I have downloaded one of the later versions of QGIS, and if you go to About, you can see it is version 3.32.1 Lima. And if you've seen any of my previous videos about the QGIS, you probably know that a lot of these versions name are based on world cities. So in this case, it's Lima, Peru, it looks like. Okay, so that's the version I'm going to be using. I'm running on a Windows system, 64-bit. And as you can see from my screen, there's nothing here. So as you can see at the bottom of my screen, it tells me that there's another version out now, 3.32.3. So it's probably a minor changes, so I'm not going to download that one. In order to write scripts, what you can do is, okay, let me take one step back. There is, in QGIS, if you look at the bottom of my screen, there's a Qt designer with QGIS 3.32.1 custom widget. So you can actually download a designer that you can build GUIs from. And if you do, you'll get a modal window like this, and you can choose what type of framework you want to use, whether it's a main window, what have you. I'm just going to close this and bring in the actual designer. As you can look here, there is layouts. You can do vertical layouts, horizontal. So you're basically going to build form-based. Back in the day when I started, there was a server-client kind of thing where you had database background and then you had a front end. Maybe it was a VB front end, or Windows form front end. Here, this is the Python version of that. And it's based on something called Qt or Qt. The latest version of Qt, which has basically two flavors. There's something called PySide, and then you have the PyQt number 6, I think it's now. I'm not going to touch on form-based kind of thing. I'm going to use a widget though. I'm going to use one of these widgets in my presentation today, but I'm not going to build any framework like this. So let's close that. You can figure out about the Qt designer by going and do some searches. All right, so I'm back here. In order to run scripts inside this environment, there is a button up here, as you can see, that is a Python button. And this whole application, the QGIS, has written a lot of Python code in the background of this. So that makes sense that you can include Python as well in here. So when you click on this Python button, you get in what is called a Python console. So you can see here, this is the Python console. And if you write something and run it, and I get something like this, I can get rid of all these errors, for example, by clicking this paintbrush here. And now it removes whatever I had on the output. This is the run button. This is a show editor, which is we're going to be using. And here you get some options. And when you click on the options, it will look something like this. And it has all kinds of settings here. The one setting that I'm going to be using that I have changed is this code editor, as you can see down here under the IDE. And I have changed the Python version of this. Down here is where you can set your custom colors. And up here you can set your font type. And I set it to 14, so it's a little easier to read this. And I changed all the default colors to use my own. So as you can see here, if you have a single quote, I'm using this red color. If it's a double quote, I use this red color. And then you can also have like triple double quote or what have you. The way you can change these colors, if you hover over this button here, you can see that you're getting different flavors of how to set the colors. You can use hex colors, red, green, blue, RGB, or there is a third kind, the HSV, which I'm not too familiar with. But that's another method you can use too. Now, you can click either on this button and you get this particular form where you can start using like a wheel and change it that way and save these colors. If you want more choices, you can also double click on this one And that opens up a bigger dialog form where you have different ways you can navigate to the color you like. Here you can see hex colors and so forth. One thing I did down here to get this red one was simply go and click here, and then I went here and I simply copied the HTML notation, and then I went in and I opened this and I just pasted it here. That way I got the same kind. But you can also use things like this, where you have like this thing that will find the color by you hovering over it and selecting it. And then once you get it, you apply it and you're good to go. So you can set up your environment here. So that's what I did with my text editor. Okay, let's go back and get to that code editor. So if you look here, this here is just for docking. This is if you need help, and the options we already just looked at. This is the one I want to use, this code editor. That allows you to write scripts. And in order to write a new script, you simply click there, and the plus button will open up another script, and then you can save it with a .py extension. So what I have done is I prepared a few scripts that I want to go through. So we're going to start at the first one, and then we're going to work our way from part 1 to part 2 to part 3 and so forth. And I'll go through that. But let's start with this first one here. Now, this particular script is my starting script for creating shape files from the Census Bureau's shape files, the Tiger files, which I have used in previous videos as well. So I have this TL RD22 US County shape files sitting on this path here. I have a lot of these downloaded from the Census Bureau, and you'll get here and then you simply drill in, get to the shape files, and once you get to the Tiger files, you can, it doesn't much matter what year you choose there, because remember, there might be some updates, but a lot of these are created right after the census was taken. And we know that there was a 2010 census and then there was a 2020 census. So I don't know if you're going to go much wrong depending which year you choose, but you can choose the latest one. And in order to get to it, you can go and choose, what you're looking for. There's technical documentation, and then you can go and get the actual files. So you can go, for example, click here, for example, get to that folder, and here you have all the files. There is also other ways of getting to this, and I showed that in detail. I think it was in Geospatial Data and SQL Server Part 2, I think it was, that I discussed how to get to the Tiger file. So check that video up. I put a link on it for you in this video. The one I went to was this county folder here. And when you go there, you can see you can download this stuff. So I downloaded this one, the TL_RD22_US_county. That's the file that I'm going to be using. So that's how you can get to that one. So once you get to that one, it's going to be sitting here. You're going to load this shape. So what I'm going to do is I'm going to basically import some libraries here from the QGIS. Now you can mix this because QGIS has their own plugin, and there's also, like I said about that Qt, they have their own libraries too. There's something called Core, there's something called GUI, there's a couple of others too. But it all depends on what you want to. These are like different libraries you load in. So you have this vector layer. I'm going to be using some coordinate reference systems, so I won't need to do some transformation. And there's also this QGIS feature. Now, if you want to learn more about this, I suggest you either search for this, and if you do, let me just show you quick. If you say search for this one, and you hit enter, it takes you to this QGIS website. So notice it's a class, and if you drill in here, they have all these listings at this website for the classes. You can also search Google, and you can also go into ChatGPT and those type of places. That's probably a good place to go to get some code, because it's not easy to figure out this code. It takes time, and it's easy to get the wrong code because there's so many versions and they change this sometimes. So it's hard to stay up with it. So let us just go quickly through what this does. Okay, I'm importing these libraries. from the core, I'm importing this from the QGIS cores that's part of this install. I want to navigate to this path, and I want to get that shapefile that came. Let me do this quickly so you understand in case you don't have too much experience with this. If you go here, and let me just open this. When you download these S3 shapefile types, you're going to get one that has the data. The DBF stands for database file. And there's a couple of other ones, projection. That's how it's recorded. And if you look at this projection, let's just open this with a notepad, for example. If you look at the projection here, you can see that it's using the NAD 83. You can see it right here. So it uses the NAD 83. And this is the North American datum of 1983. But what I'm going to do is I'm going to make it a little more specific in my case. So I'm going to change this. I'm going to transform it. This is the shapefile we're interested in, and the rest of this information will be dragged in with it. So if I go back now to my QGIS, and I import this into this path, and then I actually use what is called iFace, and that's kind of the overall reference to what you're going to be doing in here. Now, if you want an ugly output about what iFace is all about, you can simply type in the console here, EIR iFace, like this. And when you hit enter now, notice, this is all the stuff that it will do. So as you can see, there's tons and tons of stuff that this iFace is doing. So basically everything goes through this iFace inside this area here. So that's what we're going to be using. So I'm going to clean that out. And if you look here now, I am adding a vector layer. So that's one of the things that iFace is doing. And the vector layer, if you look at it, if I remove this and put that in again, you can see down here what it's requiring. QString, QString, QString will create this vector layer. But you can also click this down here. This one happened only to have one here. These are the methods and so forth. So what I'm doing is I'm putting in my input path, which is the shapefile. This is what I want to call it, the layer I'm creating, and I'm going to use the Ogre interface to do this. And this comes from GDAL, by the way. Once I get this layer, I'm going to filter it by using the set subset and setting the state FP to 17. The reason is that there's a field in there called state FP, and it has a number, and for Illinois is what I want, that is number 17. I also want to create a transformation from the existing coordinate system, which I think is 42 something, which is a NAD 83. But I want this specific one, which is going to be East Illinois. So I'm going to convert that into this. And I also going to create a new layer based on this filtered layer up here that I want to spool out. I want to save it. And what I can do is I can create in-memory layer, call it Illinois counties. And I'm going to be using this format here. Now, I also am doing a transformation. So whether it happens here or not, it's probably going to happen down here. But I'm not sure why this is not really working. So, but it runs, so I'm just leaving it in there. I'm also going to make sure I capture the data that goes along with that substring. Otherwise, my attribute table will be empty. So what you can do is you can use this data provider that belongs to the layer, and I'm going to add the attributes that are the fields from this filtered subset here that we call US counties layer. This one, I want to get those data. So then I update the layer, and then I'm doing a transform. So I'm creating a transform using this coordinate transform, and then I'm passing in the original one, the filtered version of it, and its coordinate system. Because if you look what it's requiring here, you can see it's going to ask for a reference system, to and from reference system, basically. So this is the to, this is the from, and this is the to. So I want to get the whatever this one is supposed to be, which is this, okay? So that's the one I want to use. And I'm going to use this instance projection here Don't ask me why, but that's what it requires. So this one seems to work. So I'm going to do that, and I'm going to do a for loop for every feature. Every feature is almost like every columns and so forth. So for every feature, I'm going to get those features from this layer, the U as the original one. I'm going to get the geometry from it, and I'm going to do the transformation here. So by running this code, you'll be able to transfer from one reference system to another. Once you get down here, I'm creating an output file path where I'm going to save this to. So I'm going to save it to my export folder, Illinois Counties shape. And in order to save the file, you use this QGIS vector file writer, and you write it as a vector format. You're passing in the file you want to save and where it's going to go. And this is a UTF-8, the text portion of it. And then I want to use that new coordinated system that I did in my transform up here. So that's the one I want to use. Because you can see I added it to the layer right here. So it's going to be S3 shapefile format. So it's going to try to generate those 5 files that you've normally filed. Okay, so enough said. Time to try this out. So let's try it out. And here you can see it took that original file and it filtered it and it put it into this one here. And if you look at it, if we go to properties, you can see that the version now, it sits at the NAD 83, 4269. But that's not the file that we created. That's the original file. That is actually the sub-filtered file. This one is the U.S. counties, as you can see, this one. I'm interested in this Illinois counties. So I want to get my file that I've just generated, which is this file right here. So you could either look it up here, or we can just drag in the shapefile here. Then we can uncheck the U.S. counties, and we can go to the Illinois counties. And if you go to properties now, you can see that the projection is now 3435 Illinois East. So we converted it into this format. And another thing that we have too, if you open up the attribute table, you're going to see here's all the counties in Illinois, all 102 of them. And as you can see, here's the 102. So what it did was it generated this file, and it has about 17 columns. And this is what it looks like now. These are all the counties in Illinois. All right. So that's the first file. Now we have generated it with a different format. And the reason I converted it is to try to do some area calculations based on the information in the attribute table and also based on information in the actual geometry of this state's counties. So the next we're going to be looking at is how to add those calculated fields into that attribute table. By the way, I'm going to make the code available on my GitHub repository in case you want to dig into it. Now, the second thing is this add the calculated fields to this shapefiles. So in order to do that, I set up this second script here. So I'm going to import the OS library. I'm creating a working directory like this. Now, you don't have to do this, but I just did it to show some variety. Then I can set the working directory here by doing the change directory and from the OS library and passing in the descriptor here, the path. Then I can create a file name, combine the two, and then I can create an out file name when I save it again. So that's going to be a shapefile. I'm going to save it again after I'm done with it. So what I'm going to do is I'm going to be working on the existing one that has those 17 columns. And then I have this little script that I usually put first. And what I will do is, if you have a bunch of layers here, like I have 2 in my case here, the U.S. counties and this one, what I can do is I can remove all of them. So, for example, if I make some duplications here, and maybe another one. Okay, so now there's 4 layers, and it's just, you can see them right here. The first thing it's going to do is remove all those by looping each layer using this project and finding all the map layers and get the values. And then it's going to basically remove it. You can use this code here to do that. Then it's going to refresh the canvas. So what I need to do now is load the Illinois counties again because I'm removing it from here now. And then I got to load it again. And the way I do that, of course, is referring back into this file name here. So I'm going to get it from here, just like we did before. Now, the next thing we got to do is every time I run this, I don't want to have stuff sitting. So in case I test this, I don't want to have fields sitting in this shapefile that I don't want, because I'm going to repeat this maybe. So what I do is I just create a valid field list. These are the field names I want to keep. Now there's 17, but I'm not going to keep all of them. I want to specifically keep these field names. Now this land and this water is important for the area calculation, and I'll talk about that in a little bit. Here, I'm going to capture all the field names, which is more than this group here. And then I have this delete fields list. And I'm using a list comprehension here. As you can see, item for item in all fields that are not in this one. Those are the ones I'm basically gonna be deleting using this function. So I create a list of the things to delete. So now I got that list. And for each item in that list, I'm going to call this function here, delete field. And I'm passing in whatever the field is that I want to delete. And I'm capturing the index from that field name here. And then I use this data provider to delete that fields based on this index. That's what happens here in this part, right there. And then the call is here. All right, so once I got deleted all the fields that I don't want and only keeping these guys, then I want to add some fields. So how do you do that? Well, the QGIS seems to have many different variety of methods you can use for things. So it's not one way to do it all. So what I'm doing here is I'm saying I want to add some attributes to this data provider that I call PV up here. So if you look up here, you can see I created a layer data provider here. So I'm going to use that for that layer to add fields to it. So I'm adding attributes, and then I'm using my QGIS field class. I give it a name, and then the type it is. So in this case, it's long. I don't know if you need that, long, but whatever. I get some code snippets from somewhere, and that, whatever that is, it seems to work. But what I want to do here is I want the area in kilometers and I want the area in miles. I want the geom kilometers and geom miles. So what's the difference? The area is based on the internals of the file. What I mean by that is the way we're going to do this is that comes from the Census Bureau. So the area has already been calculated. And if you look here, there's A land and A water. And we're going to add those two up, and I think it's in meters. We're going to add those two up, and then what we're going to do is we're going to combine the two for a total. And that's going to be what I call the area calculation. And we're going to do this in miles and kilometers by using conversion factors. Now, this calculation is going to be based on each individual county's shape here, the geometry, in other words. So that's a different calculation than these, because these I'm going to use the numbers inside that table, the attribute. Here I'm going to actually calculate it from the polygon itself, the shape. So it'll be interesting to do and see if it actually will match or not. So this is what we're going to be doing. So I'm going to have this A land and the A water. So that's those two. It's not square feet. I think it's square meters. So I think that's a mistake. I'll fix that later. But what we're going to do is we're going to total area, add that up. And then we're going to use this, which is going to be, I should change this, meters. So, I mean, I wouldn't really look too closely at this. Just follow what I'm doing here, and you're going to be able to do it. Because I basically, once I calculate the miles, I simply convert this by using this factor, which is pretty much this factor here. So let me see how many. 1, 2, 3, 4, 5, and then 6. 1, 2, 3, 4, 5, and then 6. This conversion was used for square feet, not meters. So that's why this one is not correct. I'm going to take that out. I don't want this one here. That's wrong. This one is okay. So this is not correct either. I have to go back and verify that is in meters, not square feet. In any event, this is the conversion that we're going to use for the area in miles by adding those two fields up and then multiply by this conversion factor. What we can do is, like I'm doing here, you can see I'm creating a variable and I'm setting equal to an expression. So these expressions will be handled internally. And for the geometry version polygons here, to calculate that, you can use this $area. It's like a fixed variable in there. And that one, by multiplying by these factors, it will use the shape, the polygon, in other words. But let's just do it this way. We're using expressions. So as you can see, we do the conversions. We create a context. And then you append to that context these expressions. So basically, this stuff here is going to use those expressions and do the computations for you. And then once you're done with it, you can see here, these are the area and all that stuff. And what we're going to do is we're going to use this context and basically calculate these expressions. So I'm giving it a name. Total area is going to be equal to this variable. Area in kilometers is going to be this value. Area in miles is going to be this value, which is calculated up here. And the geom kilometers is going to be here. And the miles kilometers is going to be here. And these are the values. These are the field names. So that's the list I'm going to be using. Then what we do is basically calling this function, passing in the field names and passing in the formulas, whatever that is. Then with edit for the layer, loop the, get through the features, use this context, and then evaluate the expressions in the context, and then update the layer. So this code works, and I don't want to dwell on it because this is just the way they do it, I guess. Here, if you look here, I have a list of tuples with a field name and a value. As a second tuple, field name value. So because of that, I'm basically grabbing the 0 base, which is the field name, and the 1 base, which is the value. And that's what I'm adding in here, that I'm calling and adding in here. So that's why you have two values here, because it's a tuple. Okay, so once you get down to the very end, I'm simply going to write out the new layer. We're not going to change the geometry, but we are going to change the attribute table by adding fields. And that's what we're doing in this particular file. Okay, so let's run this now and see what happens. I'm going to run it, and it's done. And here, remember, it looped through all those layers and got rid of them up here and refreshed it. So now what we have is a new shapefile that has, it should have more than the column. It should have those columns I listed, which are these, plus those 4 or 5 other ones. So let's take a look and see what it looks like now. So let's open the attribute table. And you can see here, this up to here is where it was the last one, was up here. And what we're interested in is the new stuff we calculated. So we have the land and we have the water. You add those up. That was one of the computations we did. We did the area in kilometers, and we did the area in miles. So if I look at something like, let's find one that I'm very familiar with. Let's go to Lake County. So let's sort this, and let's find Lake County. And we got, here's Lake. And let's bring it up in the form view. So if you look at Lake here, you can see that these are the computed values here. You can see it over here. I don't like the look of that. Let's go back. Okay, so as you can see, remember we did it two ways. We used the the data in here, add up the land and the water area, and that's right here, these two. This is for the miles, 1368. Then we did the second calculation based on the polygons and geometry. And if you look at the values here, you're getting the same result. So you get 1368, 3540 for kilometers, 3540 for kilometers. Now, one thing we can do, how good is these calculations? And the reason I did the geom based on the shapefile was, and did the conversion with the coordinate system, I used East Illinois to do this. So let's look up and see how good our results are. I'm going to go up in here, and I'm going to go to Lake County, Wiki. Guys, if I go to Wikipedia here and I look at Illinois, you can see if I scroll down and I look at this, there's this, if I look at area, there's the total, and look at this, 1368 square miles. What did we have? 1368 square miles. Let's put them next to one another. 3540 in kilometers. So that is right on. Sometimes you might get a little rounding or what have you, but in this case, it turned out that even computing from the shapefile for the Census Bureau, we're getting the same numbers as they show on Wiki here. So that's good news. Okay, so we got that Lake County is up here, the yellow one you can see here. Okay, so that was the second part. The next script here is the part 3. In this script, as you can see, we're going to be looking at some adding colors and label to it, to some layer. So again, I do some new imports here. I have this simple fill symbol layer. We're not going to use the gradient one, so we don't really need this stuff here. We need this one here. Do a loop run, get rid of any previous layers that are sitting in here. And then we want to load the county file again. And what we want to do next is we want to create a new layer for that file. And we want to add it to the canvas here. And by doing that, we can also create something called a renderer. And I wrote a little bit about what a renderer is here. So the renderer is taken from the active layer, which is the one that is part of this layer. And then we can use that renderer to modify the layer. So we're going to basically change the symbol. Now, what is the symbol? Well, if you open this and go to properties, and if you scroll down to symbology here, you can see this is where you can control, the opacity, the color. So we're going to just do a plain vanilla simple fill in our case. So that's what we're going to do. And then we're going to choose a color. And again, remember the colors. You can choose between RGB or whatever you want. That's what we're going to do. And we can also, for anything on a map here, if you go up here and you click this ABC on the top here, you can see you can do like a single label, and if you choose name, that's one of the fields. Here you basically have a list over whatever field you want to show in there. So if I want to show the state FP, you can see all of them are 17 because it's Illinois. So basically we want to use the name, okay? Okay, so that's basically what we're going to do, but we're going to do it in Python. We're not going to do it here. So let's get rid of the labels here, and let's just take that out. No labels. And let's close this. And then what we'll do is we'll go and look at the script again. We're going to render. We're going to use the symbol. I am going to not use the gradient stuff, so let's take that out. By the way, you can do a quick, you can either comment out stuff by simply clicking this thing here, or you can say it says Control+, colon. And as you can see here, we're going to set the color based on RGB schema here. And what we're going to do is we're going to do a simple fill, and we're going to change the symbol layer. So we're going to change that. Also add some labels here. So we can use this PAL layer setting. And field name is going to be name, like we said. That's what we want to show on the as a label. We're going to enable the labels. We're going to set it equal to true for the layer. And then we're going to actually add some layers here, and then we're going to repaint. I'm sorry, add labels, and then we're going to repaint. So that's basically what this is doing. Now, let's see if this will actually run, because I changed some code here. So let's try that out. So we're running it. And as you can see, it changed the color to a darker color, and it put the labels in, as you can see here. So we can zoom in a little bit so you can see it a little more. And as you can see, oops. As you can see here is the counties with their names, and the color changed too. So that's one thing we could do in this particular script. And the next script I want to do here is to create some interactivity. And what that boils down to is that I want to be able to, based on selecting something on this map, I want to execute some code. So that's what we're going to be doing in this script. So as you can see, I wrote a little description here about how this functions. There is this QGIS map tools that has events you can attach to them. So basically this map tool takes two arguments, the canvas and a layer. The canvas release event method is when you click on the map, it will calculate your position on the map. And you can read the rest here yourself. And what we're going to be doing now is import the map tool from this GUI, QGIS GUI. You're going to import it. Then there's a class written here, and I got this code from somewhere. So this is not really my code, but it seems to work, so that's fine. Here is where you find the position on the map you are, the X and Y position. And here you do some coordinate transformations. So there's some calculations involved there, and you can look at this. But it's basically a 4-feature loop here for all the features in the layer. We're looking to find the name column. And what we're going to do is we're going to basically set a reference to an external website. So here I set a reference to the Wikipedia page. And what I do is, you can see here is the county name. What I'm interested in doing is to populate this URL with whatever you're clicking on the map. So I capture the county you clicked on here, and that's the one I'm going to pass into this URL here. And the rest of it is just boilerplate code that gets to that location. And then I want to print out the county we chose, and I want to print out the URL that we created. And then I'm going to open that URL by using this QDesktop Services Open URL method and your QURL object or class, and pass in the URL. And then I just break it on here. And finally then, you set the canvas equal to the map canvas, and you project the instance of the map layer by the layer name of Illinois County. And you say if layers is, if you set it into equal one layer, in other words. And then you pass it into the county map tool, the canvas and the layer. And when I say layer, remember that you have one state shape here, but you break it into many sub-polygons, if you will, and those are the counties themselves. So you need to separate, you can't just, otherwise if you click on this map here, it will treat everything as one shape. We are interested in finding the sub-shapes within that shape, and that's kind of what this is doing. So let's run that and see what happens. So I'm going to click Run. And right now it's activated. So what do I mean by that? Right now it's waiting for me to do something. So when I hover over the map here, you can see I have this cross. So if I go to Lake County here and I click, you can see it opens up the Lake County, Illinois Wikipedia page. That's one page I can do. And you can see I tried to do some conversions here. So if I go to a different county, let's say we go to where the city of Chicago is, Cook County, click there. And now I'm in Cook County. So as you can see, you can do some interactivity, even calling external web pages here. And of course, you could do this with anything pretty much on the web. You can just have to set a reference. As long as you can capture the actual click event and capture the property of that event that you want to pass on to the URL. So that's one way. We're passing it in and we're doing a URL. Okay, the final script I want to go through is this Wikipapa Part 5 Python script. Now, it's kind of similar to the one that we did in Part 4, but instead of going out to the internet and looking at the Wikipedia, now we want to try to get some data from Wikipedia and use it within our application here. So I created this final script here, and as you can see, I have this repeated here, this information, similar to the one I had in the previous one, mostly. As you can see, we're going to import some. Actually, we don't need this one, I believe. Just leave it in here for now, but I don't think we'll need this. I started with this one, but it gave me plain text, so I didn't want that. I want to be able to format the text, so I use this text browser, so QText browser. And you get that from the QGIS PyQt Qt widgets library. And I also import some fonts, the class, so I can create font, the font I want. And I also import the Wikipedia API. There's also something called QGIS map tool. And I also want to use, in this section, I want to use Python's built-in regular expression library, so I can do some manipulation of text. All right, so we'll start here, and then I create it's kind of misleading because I'm not using a message box, but I'm using a text browser, but I just called it message box. I set up my font, the one font I want to use, referring to this class, and I looked at some of the fonts out there on the web, on the wiki, and I kind of copied it over, and I used the sans serif 12. I do believe it's using that. If not, it's using some kind of default, but I pasted in like this. So you're setting the font for the text box. Then what we do is we're going to set up a window. So I'm creating a window of 1080 by 800 size, as you can see. Then I'm using my wiki calling routine here, call it wiki HTML, because I want to extract out HTML in this case. I don't want it to pure text, because I want to be able to lay it out in a certain way. So I'm going to extract HTML. And you can do that by having this set up like this. Wikipedia API.extract format, the type HTML like this. This stuff is just taken from the sample code out there on Wikipedia API. You can find that little snippet of code there. So I just use the same one, and it seems to work, so I'm okay with that. Then I create a function. It's called find total area, and I'm going to pass in a section of the data that comes back from Wiki, and it's going to be the geography section. I'm going to set that into this text variable. Then I'm going to run a regular expression, as you can see here, where I'm searching for the wording total area of, and then whatever digits, like a regular expressions using backslash for escape character and the number of digits, followed by a comma, so that could be alternative, plus square miles. And then I pass in the text into this match RA search routine. And if I find it, then I create this variable for that group. So it uses it like a group find. And then I replace this variable, the content of where I find the actual value of the area. And then I just slap some bold in front and after, HTML bolding, because I want to see that the square miles in bolded text. So that's what I'm doing here. And then I'm returning the text. Here is another routine. This is the one that actually calls the wiki. So I'm passing in the page name, and the page name comes from the calling routine. So let's go get wiki info. And down here, you can see get wiki info right here. So I'm going to load the output into this variable here. I'm going to pass in the page name, and the page name comes from another function that I call down here. Actually, it probably comes from the actual clicking event. So the page name, show info box. If you see down here, show info box, passing in a feature. So it's a function upon function here. So the bottom line is, without getting too detailed, you can scan this code yourself. This is kind of where I'm capturing the release event. It's going to find the actual position of where I'm clicking my mouse. It's going to grab the X and the Y position, and that's the X and Y coordinates that's going to go in to the map and extract out the name of that county. And if you see here, this one translates it into coordinates. And to find the location here, I'm looping the feature selection in the layer. So I get all the features in the layer here. And if the feature's geometry contains these points that has been converted here, then I'm capturing the county name based on the feature name. And you might recall that from the attribute table. The feature name is this one here, right here. That's the feature name. So I'm capturing that. And then I'm printing out here just so I can see what I'm getting. I'm printing out the county name. And the display feature is a functions that I'm calling, where I'm passing in the county name and the layer. So display feature, as you can see up here, here's display feature, passing in the feature and the layer. And this one is going to call this function that's going to show the actual text box that we are creating. It's going to pass in that feature to it. So if you go to the show info box here, I'm getting the page name. And here is where I'm calling the wiki to get the HTML from wiki. And here you can see I'm setting as HTML, the wiki info coming back. And then I'm showing the actual pop-up box. So here's the main function that does this. I'm using a technique that you can find out on Wiki, where I'm getting the section by name. So here you can see I'm getting it by geography title is one of them I want to use. I also want to get the Wiki summary for that county. And that I'm capturing here. And then I'm saying find the total area is the function that's actually going to go in and do the bolding and so forth with the regular expression, as you can see above here. So there's a lot of code here, but okay, you understand the gist of it. And here I'm just basically creating the output of what I want to see. So let's run the code and see what we're getting. So I'm running it. Let me put a in here. And as you can see, it's reading the text of this script. So if I select one now, maybe I'll use Cook County. So I'm clicking inside Cook County. And as you can see, the text comes pretty quick back. And here's the summary of Cook County. And here is the geography section that we created. And notice that because of my regular expression, I'm bolding the square mile section down here. So for example, let's do one more so I can demonstrate something here. Let's do maybe this county, Iroquois County, Illinois. I don't know how you pronounce it, but that's as good as I'm going to get it. And here you can see again, I'm bolding the miles, and here is the geography. Now, if you want to compare this to the actual wiki, you can see here, this is the actual wiki page for that. And as you can see this piece here is the summary right up here. And then it has like a history section. And then you can see down here is the geography. So that's what we're capturing over here. And you can see this is the, this piece is the one that I'm bolding here, okay? So yeah, so you can go and get data from the internet too, and you can use it with your applications in the QGIS. So I hope you enjoyed this video, and if you did, give me a like and maybe consider subscribing to my channel. And I will be back soon with another video. Thank you for watching.